with the Paleontological Society of Southern Africa meeting that is being held at the University of Stellenbosch in Cape Town. And I'm absolutely thrilled to have with me John Anderson. Now, John and his wife Heidi Anderson have written all these wonderful books about the history of plant evolution in Southern Africa and also in the world, not just Southern Africa. But one of the really important things is that they've given us an unprecedented account of the diversification of plants. John, do you want to share with us some of this knowledge that you have? I know you have so much to say about plants, but can you tell us something about them?
Okay, shall we run through time here? There's the end Permian extinction at 250 million years ago, 252 million years ago. There's the Glossopteris flora, which completely dominates Gondwana.
In the Permian?
In the Permian, occurring right across Gondwana. And then it essentially disappears at the end of the Permian, as do many insect orders and so on as well. And then we come into the Dichrydium flora in the Triassic, which again spreads right across Gondwana.
And what do you think is it that makes the Dichrydium flora so successful in the Triassic, whereas the Glossopteris goes completely extinct? Do you have any ideas about that?
Well, of course, we're starting it. It's like a teacher cleaning the blackboard. Most of the plants are gone. Most of the animals are gone. Let's say 90% of species are gone at the end of the Permian. And there's a complete new ecospace to fill globally. And Dichrydium just happened to be extremely successful at doing that.
And there's no trace...
Along with a lot of other classes of plants as well. That's just one class of plants.
One class, exactly. And the richest diversification is certainly in the Triassic then.
And late Triassic.
In the late Triassic.
Late Triassic, at the time of the Multino, at the end of the Permian, 90% of everything gone. And then there's an exponential radiation of new diversity through the Triassic. And the Multino is pretty much at the peak of that. And that is pretty much at the time of the origin of the dinosaurs, at the origin of the mammals, at the time of the greatest diversity of beetles up until then, more or less the same kind of diversity of beetles today.
Wow.
And beetles today, of course, are the most diverse of all
orders of insects.
Orders of insects, of just about anything. And it seems to be the same down there in the late Triassic.
And then flowering plants come much later then, isn't it?
They possibly have their origins at that same time, just like the mammals, pretty much at the same time.
In the Triassic?
In the Triassic.
But the height of diversification, basically...
Middle Cretaceous.
Middle Cretaceous, yeah.
Say sort of 100 million years ago is where they really radiate to great diversity through to today.
And of course, with them are the insect diversification, isn't that true?
So at that same time, when the flowering plants radiate to diversity 100 million years ago, Middle Cretaceous, the insects originated way earlier, but at that same sort of time, the pollinating groups, the big four, the butterflies, the Hymenoptera, including the bees and the wasps and the ants, and beetles to a lesser extent, and other things to a lesser extent, they all radiate to great diversity along with the flowering plants.
And
they really co-evolve these. So the insect originated around about 450 million years ago. And this represents different orders, these major branches in this tree, time tree, get slotted against time, the major orders of insects. But particularly interesting here in terms of the flowering plants, if you see these tight branches over here,
exactly.
These are the major pollinating groups of insects.
And we see the butterflies, we see the
wasps, the bees, the ants. This grey bar here represents the moment of great diversification of the flowering plants, and you'll see that this coincides exactly with that. This great branching here coincides beautifully with that.
So this actually is the co-evolution of plants and pollinating insects and plants, actually.
Absolutely so. Yeah. And if I may just digress for a second, I've just come back from London a few days ago and visited Kew Gardens, which I dearly love, Kew Gardens. And they've got a lovely, great new sculpture, a beehive, huge thing.
To understand.
A huge concern of mine is the current sixth extinction. There, for instance, flowering plant meadows in England during my lifetime have, according to Kew's data, have 97% of it have disappeared. These beautiful flowering plant meadows. 97%. There's a great diversity of bees that exists because of these flowering plant meadows.
So I guess their numbers are also on the decline then.
They're in big trouble. And we're in big trouble if the bees disappear.
Exactly.
So if we wipe out the meadows, we wipe out the bees, we wipe out ourselves.
Exactly. No, it's really fascinating to understand this whole diversity of life and to understand how fragile our planet is. So thank you very much,
Not
John.
the planet, our world.
Our
Not the
world.
planet. The planet will carry on happily.
Exactly.
But our world.
The biodiversity on our planet will change for sure. Yeah. Thank you very much. It's been wonderful talking to you, and I think it's been absolutely fabulous to hear all the experiences that you have, not just about plants, but about insects and just modern fauna as well, and flora.